Hey everybody, Mr. Rivers here. Welcome to the first day where I am not in the classroom. I am at home right now. You just left the Google Meet. I will remain in the Google Meet the entire time, so if you have any questions about anything at any time, please pop back in and let's talk about whatever it is you want to talk about. So please make sure that you are taking notes actively. Make sure you are fully engaged in this. Your phone should not be out. If you're at home, I would like your phone to be out of your room. If you're at school, it should be in your backpack or something like that. Make sure you're not browsing the internet. Make sure you're not communicating with friends. This is a 75-minute class period, and you need to be fully committed to improving with respect to honors geometry. This is a difficult course, and if you are fully engaged, you will do very well. If you are giving less than your best, success becomes more of a challenge and less likely to happen. So here we go. Section 3.2, 3 ways to prove triangles are congruent. As you're going through this video, pause it as needed. If I'm going too fast at any point, you can pause it, you can back it up. If there was a concept you didn't fully understand, listen to it more than once. It's a video, right? So use that to your advantage. So 3.2, here we go. When proving triangles are congruent, you're only allowed to, I'm going to say assume I think is a better word than mark. Assume two items in the picture. Those two items are vertical angles and reflexive sides. And we'll talk about what reflexive sides are in just a moment. Reflexive sides. Another way to say reflexive sides are shared sides. Shared sides. Okay. And this goes along with all the other things we're able to assume in the past. The biggest being straight angles, right? Lines that appear to be lines. You're going to assume they are lines and not 179-degree angles or something like that. So lines that appear to be lines are lines, meaning they are straight angles. They are 180 degrees. Make sure that you check that all sides and angles have corresponding congruency marks. What does corresponding mean in this um, context? Means the same, right? So if we have one arc for an angle, make sure its corresponding angle also has one arc, meaning they are congruent. In this case, corresponding and congruent sides, one tick mark and one tick mark, three tick marks and three tick marks, etc. All right, so we have three postulates for proving triangles are congruent. The first is the side, side, side triangle congruency postulate. With the side, side, side postulate, we have three pairs of congruent sides. That's where side, side, side comes in. So let's take a look here. AB has one tick mark. DE has one tick mark. AC has two tick marks. DF has two tick marks. BC has three tick marks. And EF has three tick marks. Side, one tick mark. Side, two tick marks. Side, three tick marks. Side, side, side is satisfied here. So I'm going to start out the triangle congruency statement. Triangle ABC is congruent to, see if you can write the other half of that congruency statement. Pause the video now, write the other half there. Okay, let's take a look at A. A is first. Where is A? A is where one tick mark meets two tick marks. Well, where is one tick mark meeting two tick marks? One tick mark meets two tick marks at vertex D. So D should be first. B was written second. What is B? B is where the one tick mark side intersects the three tick mark side. So that is where B is. The one tick mark side intersects the three tick mark side at E. So E should go second. Where is C? C is where the two tick mark side intersects the three tick mark side. The two tick mark side intersects the three tick mark side at F. So DEF is what you should have there. All right, take a moment now, and I want you to write another congruency statement for these two triangles. Write another congruency statement for these two triangles just to have a little extra practice. All right, pause the video now and try that. All right, I'm just going to jumble it up here a little bit. I'll write B AC is congruent to triangle. Okay, well, B is first. B is where one tick mark meets three tick marks. One tick mark meets three tick marks at E, so E needs to go first. And if you look up above, B was second, E was second, so they still should be in corresponding positions. I put A second, so A is where one tick mark meets two tick marks. D is where one tick mark meets two tick marks, so D should be second. And if you look up above, D was first, A was first, A is second, D is second. And then finally, it's going to have to be C and F. Okay. So I just want you to know, like, ABC is congruent to triangle DEF. That's not the only congruency statement that works. There's a few of them. This is one example, but as long as B is in the same position as E, A is in the same position as D, and C is in the same position as F, as long as that is occurring, your congruency statement is correct. Example 1. Given that IK, all right, let's mark this up. Given that segment IK is congruent to segment AK. Okay. Also, given that IT is congruent to AT, we want to prove that triangle KIT, which is a triangle up above, is congruent to triangle KAT, which is a triangle down below. So if we're trying to prove these two triangles are congruent, we've got one pair of sides are congruent here, KI and AK. We've got a second pair of sides, IT and AT, so that's two pair. What is the third pair? It's KT congruent to itself. What is that property when we have a side congruent to itself? It's the reflexive property. So side, side, side is satisfied here. Notice what I did in this proof. I marked up the figure with the given information. I kind of talked my way through it, so you'll be thinking your way through it. I'm looking at what it is I'm trying to prove. I'm trying to put together a game plan of how I know these two are congruent. I know they're congruent by side, side, side. And I'm going to be using the reflexive property. So first off, the given information, IK is congruent to AK. How did we know that? It was given. And you see that with the one tick mark and the one tick mark. Number 2, IT is congruent to AT. How did we know that? It also was up here in the given information. So given. Don't jump around like that. Given. Number 3, we know that KT is congruent to itself, right? That is a shared side between both of those triangles. So KT is congruent to KT. Okay. What was that reason? Think if you can come up with that reason. How do we know KT is congruent to itself? It's the reflexive property. When a side is congruent to itself, that is what we call the reflexive property. Now, here's something you might want to do. You don't have to do this. It's just something that might help you. If we're trying to prove two triangles are congruent, we're going to be using sides and angles, right? So here we have a side in number 1, IK congruent to AK. Here we have a side in number 2, IT congruent to AT. And here we have a side in number 3, KT congruent to KT. So we know that these two triangles are congruent. Triangle KIT is congruent to triangle KAT. We know that because of the side, side, side congruency postulate. I am going to write this way every single time. Side, side, side congruency postulate. I'm going to write the whole name. I would encourage you to do the same thing. If you want to write CONGPOST, that's fine. I will take it if you just write SSS. If you just write SSS, I will take it, but I think it's in your best interest as a growing math student to write side, side, side congruency postulate, but I'm not going to require that. But you are going to see me do that every time. Okay. Number 2, let's talk about the side angle side congruency postulate. Well, notice S, S, and then the A is in the middle. We'll talk about that A in the middle in just a second. It is in the middle for a reason. This is not SSA or ASS. This has to be SAS, side angle side. So what we have is two pairs of congruent sides and one pair of congruent included, this is a key word here, we're going to talk about this a bit, one pair of congruent included angles. So two pairs of congruent sides and one pair of congruent included angles. Notice we have a pair of sides here, AB congruent to DE, one tick mark and one tick mark. We have a second pair of sides, BC, three tick marks, EF, three tick marks. And notice we have an angle, B, angle B, congruent to angle E, one tick mark for each of those. So what does it mean for angle B to be an included angle? Notice we have information on side AB. We have information on side BC. Side AB and side BC, they combine to form angle B. In other words, they share vertex B, which is the vertex of that angle. Okay? They share point B, I should say, which is the vertex of angle B. Same thing for angle E. We have information on side DE. We have information on side EF. Those two sides combine to form angle E, or you could say those two sides share point E, which is the vertex of angle E. So B and E are included angles. Notice the angles are kind of sandwiched between the two sides we have information on. E is sandwiched between the two sides we have information on. Notice where the A is in SAS. The A is sandwiched between the two sides. That is by design. This lets you know that the angle A has to be an included angle. Let me give you a non-example. But by the way, we can write then that triangle ABC is congruent to triangle. This is the conclusion we can make. DEF. What is vertex A? Vertex A is where the one tick mark side meets the blank side. Okay, so I put A first. D is where the one tick mark side meets the blank side. So A corresponds to D. What is B? I put B second. B is the angle that we know is congruent with one arc. E is the angle we know that is congruent with one arc. So B is second. E has to also be second. Or you could think about it in terms of the tick marks with the sides. B is where the one tick mark side meets the three tick mark side. E is where the one tick mark side meets the three tick mark side. That also works. And then finally C. C is where the three tick mark side meets the blank side. So I put C third. F is where the three tick mark side meets the blank side. F has to also be third. So as long as A is in the same position as D, B is in the same position as E, and C is in the same position as F, you can jumble this up however you want, but the corresponding parts have to be in corresponding positions. Let me give you a non-example of SAS, okay? I'm not going to change this triangle too much. I'm going to try to make it look pretty similar. So we'll call that B, A, and C. All right, so it's pretty much the same triangle up above. And then I'm going to kind of copy this one down here as well. Okay, I'm freehanding this, so if it doesn't look perfect, my apologies. Again, D, E, and F, one tick mark, three tick marks. Remember the included side, I'm sorry, the included angle is angle E here. Angle E is going to be our included angle. But if I tell you that angle F is congruent to angle B, this is side angle side, right? So side, side, included angle. This is side angle side. But this over here, F, is not an included angle, right? We have information on DE, We have information on EF. We have no information on DF. So angle F here is non-included, right? So it's a non-included angle. We do use non-included angles later, but not in side angle side. So this is not side angle side here, right? Not side angle side, because F is a non-included angle. So you cannot look at these two figures here in red and say, oh yeah, those two triangles are congruent by side angle side, because one of them satisfies side angle side, but the other one does not, and you have to have a match. Okay? All right. Let's take a look at number 2. Given E is the midpoint of RP. Okay, well there's E. Here's RP. Remember, what we're trying to prove here is two triangles are congruent. Triangle RED, which is this triangle on the left, is congruent to triangle PEN, which is this triangle on the right. So if two triangles are congruent, the way we show this is with congruent sides and or congruent angles. So if E is the midpoint of RP, what does that tell us about RP? It's been bisected, meaning RE is congruent to EP. Mark it up just like that. Our other given information, E is the midpoint of DN. So here's E, here's DN. What does it mean for E to be the midpoint of DN? It means, well, 2 tick marks, 2 tick marks. It means that DN's been bisected, meaning DE is congruent to EN. So we have a second pair of sides that are congruent. We are building a case to show that RED is congruent to PEN, and we are doing that through congruent sides and congruent angles. What else is going on in this figure? Just look at it, see what you can figure out. Well, angle 1 and angle 2, these are vertical angles, right? So angle 1 has to be congruent to angle 2 because vertical angles are congruent. Do we satisfy one of the two triangle congruency postulates that we have learned so far? We have learned side, side, side. We have learned side, angle, side. Are either of those satisfied here? The answer is yes. Side, angle, side. So a side, RE, congruent to a side, EP. A side, DE, congruent to a side, EN. Angle 1 is an included angle. It is sandwiched between the two sides we have information on. Angle 2 is I'm sorry, I think I said included side. It's an included angle. Angle 2 is an included angle. It is sandwiched between the two sides we have information on as well. So side, included angle, side. Side, included angle, side. Side angle, side is satisfied here. So let's get going on the... Actually, you know what? I want you to try this out. Pause the video now and... go ahead and complete this proof. I used every square, right? So I used all rectangles. I used all 6 of the rectangles. So see if you can try this one on your own. Okay. First, our given information. E is the midpoint of RP. How did we know that? It was given. Now, if you want to write all the given information first, that is okay. I'm not going to do that because there's a conclusion we are drawing from E is the midpoint of RP. That conclusion we are drawing is that RE is congruent to EP. Okay. How did we know that RE is congruent to EP? That is the definition of midpoint. Number 3, the other given information, E is the midpoint of DN. How do we know that? That was given. Let me zoom out a little bit here. Number 4, what did that tell us if E is the midpoint of DN? Well, if E is the midpoint of DN, we know that DE must be congruent to EN. That's a pretty bad EN. Let me fix that N. Okay. And that is the definition of midpoint. All right, now, I hope you're able to get that on your own. Again, if you put the given information first and the definition and midpoint stuff after that, that is okay, that is acceptable. I like to do it this way because number 2 builds directly off of number 1, number 4 builds directly off of number 3, but either way is acceptable. Number 5, angle 1 is congruent to angle 2. How did we know angle 1 is congruent to angle 2? Do you remember what reason we used for this? Yeah, they're vertical angles. Don't just write vertical angles though, right? Vertical angles are congruent. Okay. And number 6, we now know that triangle RED is congruent to triangle PEN, and this reason is side angle side. There you go. Moving on to the angle side angle postulate. With the angle side angle postulate, we have two pairs of congruent angles and one pair of congruent sides. Okay. Oh, congruent included sides. That's an important word there. Included sides, excuse me. So notice that just like in side, in angle, side, angle, the side is sandwiched between the two angles. Okay? So looking at these two triangles here, we have angle B congruent to angle E, angle C congruent to angle F, and sandwiched between these two angles is side BC. So this is an included side because it is between the two angles that we have information on. And EF as well. So BC congruent to EF. EF is also an included side because it is sandwiched between the two angles we have information on. So we would say that triangle ABC is congruent to triangle. Okay, let's go through this carefully. What is A? A is the angle we have no information on. D corresponds to that. We have no information on D. B is the angle that has one tick mark. E is the angle that has one tick mark. And C is the angle with two arcs. F is the angle with two arcs. So your congruency statement has to have A in the same position as D, B in the same position as E, and C in the same position as F. Let me give you a non-example of this. Give me a second to draw it. I'll just pause the video and draw it. Okay, so I'm not going to change triangle ABC. We're going to say angle B has one tick mark on the angle, angle C has two arcs, and BC has three tick marks there. So BC here is still an included side, so angle side angle is still a possibility here. But if I mark up this triangle, E is congruent to B, F is congruent to C, but if DF is congruent to BC, DF here is not an included side. So this would be angle, angle, side. So you cannot determine these two triangles are congruent. This is a non-example, right? Or a non-included side. Okay? So this is not angle, side, angle. So let me do it this way. Let me say this is not angle, side, angle because your side is not an included side. It's not between the two angles that we have information on. Okay? All right. On to example 3. Please pause the video, try this one on your own. If you need a little help unpause the video and I will give you a clue of how to start it. Otherwise, see if you can't do this one completely on your own. I did this one, let's see, I did it in 9 steps. 9 steps. That's not to say that's the only way to do it, but I did it in 9 steps. All right, give it a shot. Pause the video now. Okay, if you need some help, we're trying to prove that triangle CAT is congruent to triangle DOG. Let's find those two triangles. CAT is this triangle here on the left, this smaller triangle on the left. DOG is this smaller triangle on the right. So what you need to do is you need to find angles and sides in this smaller triangle on the left that is congruent to angles and sides in this smaller triangle on the right. So that is like the strategy of what we're trying to do. So pause the video, try it on your own. If you've already finished it, let's take a look at how this is to be done. CA is perpendicular to AT. CA perpendicular to AT. We know we have a right angle there. DO is perpendicular to OG. We know we have a right angle here at vertex O. So angle CAT is congruent to angle DOG. That's one pair of angles that are congruent. All right. All right. If you are still stuck, I used the subtraction property. So if you're looking for extra help here, if you did not use the subtraction property, pause the video now, go back, find a spot for the subtraction property, see if you can't fit it in. All right. If you did use the subtraction property and you're still watching this part, let's keep going here. We know that TO, let's find TO right there. Okay. All right, so TO, let's give that one tick mark, is congruent to AG. All right, AG is from A to G. Give that one tick mark. Okay, notice that segment TO and segment AG, they both share segment AO. All right, so when a segment, that'd be AO, is subtracted from congruent segments, so AO is subtracted from both of these, what are we left with? We're left with AT or TA is congruent to OG. So that is the subtraction property. When a segment, AO, is subtracted from congruent segments, if it's subtracted from TO and AG, the differences are equal, meaning TA has to be equal to OG. That is the subtraction property. And then finally, we know that angle T is congruent to angle G. So looking at how our triangles are marked up, angle congruent to an angle, angle congruent to an angle, included side congruent to an included side. This is angle, side, angle. So let's put this in our proof now. Number 1, CA is perpendicular to AT. That's given. What did that tell us? That CA is perpendicular to AT. It told us that angle CAT is a right angle. How did I know that? Definition of what? Perpendicular. Okay. Number 3. What was the other? And again, if you bundled your given information together, that is okay. I like doing it this way because how did I know CAT is a right angle? Well, I built it off of CA being perpendicular to AT. So whenever I'm drawing a direct conclusion from something like I do here in 1 and 2, I like to have my direct conclusion come right after that information I'm building from. Number 3, DO is perpendicular to OG. How did I know that? That was my given information. Number 4, what did I learn from DO being perpendicular to OG? I learned that, or I concluded that angle DOG is a right angle. How did I know angle DOG is a right angle? Definition of perpendicular. Okay. Let's go back to the given information. Number 5, TO. Oh wait, no, before we do that, well, if CAT is a right angle and DOG is a right angle, remember we need to show that angles are congruent to angles and sides are congruent to sides. We now know that angle CAT is congruent to angle DOG. See if you can remember that reason. How did we know CAT and DOG are congruent? It is not definition of right angle. Definition of right angle is the angle is 90 degrees. The reason for this is all right angles are congruent. This was on your test. All right angles are congruent. It is not definition of right angle. I see that show up a lot. That is not the definition of a right angle. Definition of a right angle is it's 90 degrees. Number 6. Let's see here. Back to the given information. TO is congruent to AG. All right. How did I know that? It was given. What was I able to conclude from TO being congruent to AG? Remember, we used the subtraction property, right? I was able to conclude that TA was congruent to OG. TA was congruent to OG, and that was the subtraction property. When a segment is subtracted from congruent segments, then their differences are congruent. Number 8, angle T is congruent to angle G. Let me do a better G than that. Angle G. Number 8, given. And finally, number 9, triangle CAT is congruent to triangle DOG side. No. Angle, side, angle, congruency, postulate. Okay, very good. Thank you so much for your attention. Good luck on the homework tonight. If you have any questions about anything, please pop back in that Google Meet. I'll be there until the end of the class period. Have a great afternoon, everybody.